Today in class, you learned about what complex numbers were, that complex numbers are represented by an I. Well, today we're going to be talking about different operations we can do with complex numbers, or what you do with an expression that has an I in it. So basically you treat them the same as variables. So when you multiply, you add your exponents, you combine them like terms, so you can't add a 1 to an I. But the main thing you need to do is simplify anything that has an I with an exponent. So if you see an I squared, you're going to replace it with a negative 1. If you see an I cubed, you're going to replace it with a negative I. And if you see an I to the fourth, you're going to replace it with a positive 1. So the main thing you're going to see most of the time is just an I squared, and you're going to replace it with a negative 1. So here's our first expression. Subtracting two complex numbers. We have 4 minus 6i minus 3 minus 7i. Remember, we're subtracting, so that 3 turns into a minus 3, and that minus 7i turns into a plus 7i. So it's 4 minus 6i. So you can only combine the terms that don't have a variable or don't have an I with it. So 4 and a negative 3 would give me a 1. And then a negative 6i and a positive 7i just give me a positive 1i. So we just get 1 plus I. I does not have an exponent, so I know this is in total simplified form, and that is my answer. So the next problem, too far, 2i times 7i. So as I said, it's just like if you did 2x times 7x. 2 times 7 is 14. I times I would be I squared. Now the thing we have to look at is this simplified. Well, I does have an exponent on it, so we know that I squared equals a negative 1. So I need to replace that I squared with a negative 1. So 14 times negative 1 would be negative 14. So 2i times 7i ends up being negative 14. Next problem. 2 minus 3i times 1 plus 2i. Again, you treat this just like they're polynomials, they have variables. So when we have a problem like this, we know we have to box it out. So we got a 2 by 2 box. So down 2 over 2. We have a 2, a minus 3i, a 1, a plus 2i. So 2 times 1 would be 2. 2 times 2i would be 4i. Negative 3i times 1 would be negative 3i. And negative 3i times 2i would give us negative 6i squared. So combine my like terms here. So we get 2 and negative 3i plus 4i would just give us a single I. And minus 6i squared. So now what we learned before we circle our answers, we have to look at, do we have I with an exponent? So again, right there I have an I squared. So anytime you see an I squared, you replace it with a negative 1. So it'll be 2 plus I minus 6 times negative 1, which would be 2 plus I. Negative 6 times negative 1 give us a plus 6. So I combine my like terms, 2 plus 6 would be 8. So my answer is 8 plus I. So all of your final answers are going to be what we call the real number part and then the imaginary number part. So you have a number without an I, and then you'll have an I with it. And that's how you know when you're done. One other thing you can remember, a fast way to simplify these, if it has an I squared, you know it's negative 1, so you can go straight to 2 plus I plus 6, because it's just going to change the sign of that, and then combine your like terms again, which would be 8 plus I. Last thing we're going to talk about with complex numbers is graphing with complex numbers. We graph it just like a regular coordinate grid, where your real number is graphed on the x-axis, and your complex number, so the number with the I, is on the y-axis. Some of the graphs that you see, so some equations that would have I in it, give us a graph of these couple of things, one called the Mandelbrot set, the other one the Julia set. We're not exactly going to go that deep into detail of how we would graph an equation with i's. We're just going to look at graphing numbers that are complex. But these would be the applications that you would use them for. So what we have here is a description of how you would graph this. Here's your coordinate grid. This is normally your x-axis, but we call it the real number axis, and this is normally your y-axis, and then we call this the imaginary number axis. So I have a few dots graphed here. The first one is 3 plus 2i. So the real number is 3, so I go over 3. The imaginary number is 2, so I go up 2, and that's where my dot goes. Over here we have b at negative 4 plus 5i. So when we do it, negative 4 is the real number, so I go left 4. 5 is the imaginary number, so I go up 5 and put a dot. C, I have negative 5 minus 4i. So the real number is negative 5, so I go left 5. The imaginary is negative 4, so I go down 4 and put a dot. Last one I have here, D, it's just an I. Because there is no real number, then I just don't go over any, and then the number understood to be in front of I is just 1, so then I go up 1 and put my dot. So when we look at this, I do want you to go ahead and label this. This is your real number axis. This is your imaginary number axis. So I'm going to call this one A, I'm going to call this one B. So when we look at this, the real number is 5. So that means on the real number I got to go over 5. The imaginary number would be negative 2. So I go over 1, 2, 3, 4, 5, and then down 1, 2. And that's where A would go. B is just 4i. So since I do not have a real number, that means I go over 0. And my I number is 4, so I go up 1, 2, 3, 4. And that's my B. And that's how you graph imaginary numbers. I want you guys to take a look at these couple of problems and see what you can do.